Very good morning, students. Welcome to Krishnaveni Talent School and Mastermind Schools, prestigious IIT and NEET Foundation or Focus C program. So once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware. So my subject is physics. We are in class 7th. Our ongoing chapter, the Unit 1 measurement. And today we are entering into the session number 5. Means so far we completed 4 classes, 4 sessions in understanding the concepts and applications of measurement in our day-to-day life. Right? So before going for today's session, so we'll continue where we stop in the last class. But before that, let us remind you, a gentle reminder that our monthly exam, you all know that we have one examination per month, that is last Monday of every month. But this time, due to delay in collecting the data of the number of students, the question papers are not sent yet. So that is the reason the exam is postponed to 1st August. You can conduct the examination immediately after receiving the hard copy of question papers. So you may receive by Tuesday or Thursday, Wednesday, so that you can conduct the examination on 1st August, which is purely multiple choice questions. It may be single answers or multi answers, and it is written on OMR sheets. You get question paper along with the OMR sheet, and the student is given the IDs also. They have to mention in place of that rule number, they have to mention the student ID. And after completing the examination, you can send the papers to those address given for you, so that they'll do the corrections and send the final marks list for you within 1 or 2 days. Right? So remember that exam date is 1st August, probably depends on the receiving of question papers by your branch. Okay. That is the before going for start of lesson. Now we'll move to the teaching part. That is, you can see here what we learned earlier. So far in the last few sessions, what we learned here, of course, we have done the density also in last class. Okay, so we are done with started with the introduction of measurements, then study about what are the physical quantities, various physical quantities which can be measured, then classification of physical quantities. So this is very important review class, because based on this class only we'll get the questions in the examination. And similarly, when the physical quantities are classified into fundamental physical quantities and derived physical quantities, right? Then we discuss about the very important in physics, that is unit. Whether it is a fundamental physical quantities or derived physical quantities, they are measured by a standard measurement. There is a standard measurement for every physical quantity, which is called unit. Right? It's the most important one. Then we have seen when you are writing the units also, we have to follow some conventions, some rules. The rules also we have seen. After knowing about that, we started studying about how to measure the length, how to measure the mass, even how to measure the time also we have seen. Then in last class, we discussed about how to measure the density. Right? So we are discussed in the last class about measuring of density, because density is a derived quantity. Mass, length and time are fundamental quantities. We have seen how to measure them, what are the various devices used to measure them. Okay, or what are the various methods used to measure them. So after knowing about the fundamental quantity, we entered into the derived quantity. So how to measure the density? That is what we discussed in the last class. So just we'll review that before going for the next part. So mass we have seen. So we have seen about the Now we come to the density part, right? So density already know. So density of any substance mainly depends on two factors. Two factors will affect the density. One is the space between the particles. So first point you can see the space between the particles. That is, when space increases, volume increases automatically. The space between the particles and mass of each particle. Space between the particles and mass of each particles will affect the density of a substance. So depends on the space and depends on the mass of the particle, volume changes. That is, the density is given with the formula you can see here. We discussed in the last class. So density is nothing but mass of substance by volume of substance. So mass of substance means the substance contains so many particles. Each particle mass accumulate to give the more mass, right? So m by v is the mathematical formula for density. Density is equal to m by v. We know m is measured in kg and v volume is measured in meter cube or gram centimeter cube, right? Either you can measure in MKS system or CGS system or call SI system also. Okay, so the density is nothing but the ratio of mass of the substance to the volume of the substance. Mass of the substance depends on the mass of each particle, individual particles. Volume of the substance depends on the space between the particles. If space is less, volume is less. Suppose see, mobile phone is there. Its volume is more when compared to the pen. Correct or not? My mobile phone volume is more than the pen because it occupies more space. It have more particles in this are away from each other compared to pen. Okay, that is. So the units of the density are kg per meter cube or gram per centimeter cube. That we have seen here. Relationship also given. Relationship between SI unit of the and CGS unit. So SI unit is kg per meter cube and CGS unit is gram per centimeter cube. We can convert also. We can convert the kg per meter. See, for example, kg by meter cube is there. So 1 kg is how many grams? Connect 1000 grams. So 1 meter is equal to how many centimeters? 100 centimeters. But whole cube is this, sorry. 100 centimeter, 100 cube will get 100 cube. Why? Because meter cube is there, na? So 1 meter is equal to 100 centimeter. 1000 grams will become grams. Now we can calculate 1000 by 100 cube. That is 100 into 100 into 100. You can cancel 3 zeros. 2 plus 1 0 you can cancel. So what we get here? 1 gram by how many is there? 3 cancel me. 3 are there still out of 6. So 1000 centimeter cube. That is 1 by 1000 centimeter cube. 1 kg per meter cube is equal to 1 by 1000. That is 10 power minus 3 you can write otherwise. 1 by 1000 is nothing but 10 power minus is equal to 10 power minus 3. Let me clarify. Clearly I will write. Okay, see here. 1 kg per meter cube is equal to, right? 1 kg you can write as 1000 grams I am writing, right? By in place of 1 kg, meter cube is there. 1 meter is 1000 centimeter. That is 3 cube is there. I wrote 3 times centimeter cube. So you can cancel 3 zeros. 1, 2, 3 zeros. So you get what is? That is equal to 1 gram per. Which is left down, 1000 is left. Centimeter cube. That is equal to 10 power minus 3 gram per centimeter cube. So 1 kg is nothing but what? 10 power 3, 10 power minus 3. 10 power minus 3 gram per centimeter cube. Like that you can convert the gram per centimeter cube into kilometers also. Kilometer per kg per meter cube also. So that is a conversion. That is called relationship. Relationship between CGS and MKS system. That's what is explained here clearly. Right? Clear? Relationship between SI and CGS system is given. So again, one more important information. Last point is given here. See. You can see here, last note. Density depends on nature of material of the substance. Density is not same for all. It changes. For instance, it may be different from iron. It may be different from gold. It may be different from cotton. Material depends on the nature of the material, right? So if the material is same, density is same. If material is same, density is same. But material changes, density changes. Right? That is very clear information. You can note on this very important point. Density depends upon nature of material of the substance. If the material is same, then density is same. Right? So when you move here, we have seen already yesterday. I told you to note important also. So density of different substances you can see here. Different states of matter. We can see density of solids, density of liquids, density of gases. See how the density of solids are much more greater because you see density mass of the each particle of the solid is more when compared to liquids and gases. Due to heavy mass, their automatically density also more. 19,300 kg per meter cube for gold compared to 0.0309 kg per meter cube hydrogen gas. Right. So these are the very important values of the density, which is mainly depends on mass of each particle and space between the particles. That is mass and volume. So density is equal to mass by volume. Right. Now we'll come to next part, the climax, the last theoretical topic of the chapter. After that, we have worksheets. So what is there here? Introduction to relative density. Relative density. Very interesting. So what is relative? Relative is comparing. Comparing density of one substance with density of other substance is called relative. Density of one substance with the density of other is called relative. Right? For example, you can see very important information you can find here. Right? Gopal Nagar. So what you can find, see, try to understand this passage, the paragraph, very important, all of you. So clearly they are explaining about the relative density. Most of the substances expand on heating and contrast on cooling. Very important note on this. Most of the substances expand on heating. Expand is bigger. Suppose if we heat the metal, it expands, size increases. When you cool down, it contrasts. So mass remains constant. You know, mass never changes. Therefore, density of the most of the substances, try to understand. Therefore, density of the most of the substances decreases with increase in temperature and increases with a decrease in temperature. Why? When you increase the temperature, what happened? The space between the molecules increases. Right? Automatically, the volume increases, density decreases. But see, very important, it decreases with temperature. But water, like other substances, contrast when cooled to up to 4 degrees Celsius, but expand when cooled further below the 4 degrees Celsius. Reverse for water. Thus, density of water is maximum at 4 degrees. Density of water is maximum at 4 degrees only. So below the 4 degrees, above the 4 degrees, no change. So the very important point, the density of water is maximum at 4 degrees Celsius. It is 1000 kg per meter cube or 1 gram per centimeter cube. Unlike other substances, water won't undergo expansion and contrast on heating or cooling. It is always at 4 degrees Celsius and it is maximum. If you increase the temperature, it contrasts. That is like, see, up to 4 degrees, but expands, unlike other substances, when cooled further below 4 degrees. Thus, density of water is maximum at 4 degrees. Very important point. Density of water is maximum at 4 degrees Celsius. That is 1000 kg per meter cube or 1 gram per centimeter cube. Somebody is writing on board. Okay. So that is very important point to note. That is the reason we'll take the water as a constant or reference for measuring the density of any substance. We'll consider water. That is called relative density. It is the ratio of, who is writing? So It is the ratio of density of substance to the density of water at 4 degrees Celsius is the definition for relative density. So relative density is given by density of substance by density of water. At 4 degrees is very important because you know that at 4 degrees, the density of water is maximum. So as the density is maximum, what we are doing, we are considering the density of water as reference and we are defining the relative density. Note down this definition, very important. Right? Density of substance by density of water at 10 degrees Celsius is called relative density. Again, you can convert that into mass and volume. You know, density is nothing but mass by volume. Separately, we have written mass of the substance by volume of substance, mass of water by volume of water. Right? Divided, na? See, in place of density of substance, what do you write? Mass of substance by volume of substance by mass of water by volume of water. So automatically it will come like this, right? So mass of substance, volume of substance, same thing happened here. Is into actually, not plus. So if the volume of substance is equal to volume of water, both volumes are same, then you can get the relative density like this. Then the relative density is nothing but mass of substance by mass of equal volume of water. So by knowing the volume of water, that is density of water, we can find out the density of any substance by comparing. That is, comparison is called relative density. What we can call relative density. Density of substance by density of water at 4 degrees Celsius. Right. Thus, the relative, clearly mentioned, thus the relative density of substance is the ratio of mass of substance and mass of equal volume of water at 4 degrees Celsius. Note, relative density is sometimes called specific gravity. Very important word again. Relative density we can call it as specific gravity also. There is a specific gravity bottle is there to measure the relative density. It tells how much given number is heavier or lighter compared to the water. And when you compare the density of any substance with water, by seeing that you can find out how much the object is heavier than water or lighter than water. That is a comparison. That is called relative. Okay. As you know, this is a ratio. So ratio does not have any units. Because numerator also density, denominator also density. What happened? Cancels. For example, density of substance is kg per meter cube. Density of water also kg per meter cube only. So they cancels. So no units. Ratios does not have units. Right? It is a pure number. It is a mere number, you can call it as. It is a mere number. Mere means pure. Real. So relative density is measured in number only, not in any other units. Okay, lot of information is there on this page. You can note down. You can note down the points first. First, you note down the what is the definition of relative density and formula. Then here it is about units also you can write down. And this point note also you can write down. 4 points you can note down as synopsis. Important points. 2, 3, 4. Right? You can note down the points first. The first point is about the density, relative density. It is a ratio of density of substance to the density of water at 4 degrees Celsius. Then write down the formula. Relative density is equal to density of substance by density of water at 4 degrees. Third point, relative density is sometimes called as specific gravity. Next point, as the relative density is the ratio between the densities or mass of substance, there is no units. And it is only pure number. Right, it's a pure number. Please maintain the proper notebook. Important points to write. I'm not asking you to write all the answers. Only important points so that you can refer before the examination. So exams questions all will come from this only. Nothing, there is nothing new. There is no new questions are given from somewhere else. All will come from your material. If If you are perfect in your material, you can answer the exam perfectly. You can score 100% marks. Four points. Noted. Very important. In these 4 points, 4 multiple choice questions come generally. So today we started with the introduction of relative density. Because water is having special property, it cannot expand more than beyond the 4 degrees Celsius. It is maximum at 4 degrees only. Whether it is higher than 4 degrees or lower than, it won't change. That is the reason we have taken that as a relative. And we are measuring the density of other substances by using the water. Right? Hope you wrote all of you. Gopal Nagar, Banur, I don't know, Saraswati Garu. Please, you all log in with the school name so that you can understand. Kishan Bagh, Jogipet is there, Gopal Nagar is there, Ramannapeta, and Saraswati Garu. I don't know whether it's a name of the teacher or some. Maybe, please, you can log in with your school name. You change your name to school name. You can easily change it. Right? So that you can understand what is the attendance for the classes. You can submit report. So if you have any clarification, if you have any doubts, again, these videos you can see either in YouTube also there, live is there, as well as recorded also there. And we are sharing the videos to your respective groups also by end of the day. You can forward the videos to the students, respective classes. For example, today this is 7th class. This video you can send to the 7th class students. So that if they miss anything, the absentees or those who are not understood or they want to see again, they can see in the videos. Please, teachers, you have to take the responsibility to make these classes successful. Definitely, students will get the benefit out of these classes. Okay? I'm moving forward now to the next part, the continuation only. So, numerical value of density and relative density in CGS system. Numerical value. Simple way how to get the relative density. For example, one example is given here. See here. Let there be a substance of relative density 7.6. 7.6 is the relative density. We know relative density is the number. It is not a, doesn't have units. So see, relative density is equal to density of substance by density of water. Both we are considering only CGS system now because less amount is there. So we know relative density is 7.6. 7.6 is equal to density of substance by, so density of water is 1 gram per cc in CGS system, right? So what we get density of substance is, so whenever relative density is given, so 7.6 into 1 is equal to density of substance. Simple mathematics means by knowing the relative density, we can find the density of substance, that is 7.6 gram per centimeter cube. 7.6 the relative density, meaning is its density is 7.6 gram per centimeter cube. That is the numerical value. Okay. So density of substance is 7.6. Whose relative density is 7.6. Right? Whose relative density, whose substance, whose relative density is 7.6, its density is 7.6 gram per cc. Gram per cc. Okay. Next continuation. Thus, the numerical value of relative density is same as CGS system, that is 7.6. Numerical value is same, but only density will have units. Relative density does not have units. Right? Let there be a substance of relative density 7.6. We know relative density is density of substance, same again. In case of MK system, this is. So in case of MK system, density of substance, density of water is 1000. Here we taken 1 gram because CGS system, 1000 kg here. So it becomes 7,600 kg per meter cube. Same only. 7.6 gram per cc is nothing but 7,000 cc, 7,600 kg per meter cube in SI system. It is in CGS, it is in SI or MKS. So by knowing the relative density value, we can find out the numerical value of the density by using the formula relative density is equal to density of substance by density of water. Density of substance by density of water. Clear? Thus, the numerical value is 7,600 kg per meter cube. Thus, numerical value of density of SI system is 7,600. So, in case of CGS system, it is 7.6. In case of MKS system, it is, because it is into 1000, that's all. It is 7,600. Clear? Now, another part. Relationship between density and relative density. So, density of solid is equal to relative density of solid into density of water. Because we know the formula, same formula. From here on you got it. From this formula you got it. So, you can take this side. So, density of substance is equal to relative density into density of water. In CGS system. That is, relative density of solid is into 1 gram. Whatever the relative density is there. If you know the relative density, you have to multiply with the 1 gram per cc. Or if you don't know the relative density, multiply with 1000 kg per centimeter cube. We'll get that's what they derived here. You can find the density of substance when your relative density is known for you, or relative density of substance when density of substance is known for you, because density of water is constant. Either it is 1 gram per cc or 1000 kg per meter cube. Right. Then another is determination of relative density of the liquid by using relative density bottle. There is a bottle called relative density. Right. There is a relative density bottle by which you can find out the relative density of the liquid. Okay. See here. This is called relative density bottle provided with the stopper with hole. Stopper within a cap. Right. Cork. We can keep the cork. So, the relative density of liquid is determined by using relative density bottle. Very important point again. Note down this point. How to measure that? Mathematically you can do. Mathematically you can measure. But how to find the relative density of liquid? By using relative density bottle. You can note this point. Very important point. The relative density of a liquid is measured, is determined by using relative density bottle. What? Relative density bottle. It is small glass bottle. Right. Has a stopper with fine hole. This bottle is used for finding the mass of equal volumes of liquids. Right. Whose volume is equal, you can find out the mass of them. Automatically, you will get the density. Relative density. Right. So, note on this point about the important points from the screen you can note. Right. So, when you move to the next one, some more method is there. How to find it? How to find? There is a method is given here. Method, take clean and dry. You can see you have relative density bottle. How to find the relative density is given here. So take clean and dry relative density bottle. Clean and dry, should not be wet, and weight it accurately along with the stopper, along with the cap. You have to weight on physical balance, because mass you have to measure na weight. Record the mass of the empty bottle. Let it is M1, empty, nothing is there. Now fill it with the relative density of the density bottle with the water and insert the stopper. Fill it with water and insert the cap. Then again measure. Fill the hole in the stopper and some of the overflow. Right. The water fills the hole in the stopper. Okay. Wipe off the extra water and weight the bottle. Let the mass of the filled water is M2. Empty bottle is M1. After filling water, M2. Right. Empty the RD bottle and dry it with hot air. All the remove once again, remove all the water, dry up. Refill the bottle with the kerosene. Second one is water. Water we know. Then second one kerosene. And insert the stopper. Same. The kerosene fill hole in the stopper and some of that overflow, wipe up, and its mass is M3. So M1 is the empty bottle, M2 is the bottle with water, M3 is the bottle with kerosene. You three values you are noted, right? You have noted three values. After noting three values, you have to substitute in the formula. So relative density is given by M2 minus M1, M3 minus M1 by M3 minus M1 what? Kerosene plus water minus water will give only kerosene. Mass of substance will get here. M3 minus M1 is nothing but, see, understand, M3 is nothing but mass of kerosene plus bottle minus 1, M1. M1 is only bottle. So when you remove the bottle, what will you get here? Kerosene. That is mass of the substance or dense substance will get. By M2 minus M1. M2 is nothing but water plus bottle minus bottle, water will get. Correct. So by dividing them, you can get that is relative density of the liquid by relative density of the water. For any liquid, this is the method. First you have to measure with the water, then with the some XYZ liquid, then you can find the formula here. M3 minus M1 by M2 minus M1 will give the RD, relative density of the a particular liquid, whether it is a kerosene, you can find your bomb. Either it is a cork or kero, anything you can, wood, cork, wood, petrol, turpentine, ice, olive oil, pure water. For all you can find out the density and relative density. Right. So this is the relative density. In the next class if possible. Actual thing is we have the lot of worksheets here. Worksheets you have to work on it as a homework. That is DPP I told na, daily practice problem. So today's work is practice for monthly test worksheets. There are worksheets in your textbook. You have to work on that. See, I can show you so many are there. So this is a worksheet for measurements. There are different levels are there. So these worksheets also we provide with key also. We are given the key for you. All the answers, there 58 questions are there in this chapter. Multiple choice questions. Choose the correct answers. That is match the following. Various are there. All questions we given answers also. Answers are shared in the group. The teacher can help you. And some questions we have given solutions also. Wherever required solution, we given solutions. But all chapters we provided before only. This is the first chapter I am showing for you. 58 questions. So please work on it before examination. If any time left, I'll also work on the worksheets in the next class. That is maybe on Tuesday or some other day. If we'll get the class before the exam, I'll discuss. Otherwise, you have to work on the total worksheets. We are providing even key also. First, go through the concept. Go through the concept. Read the complete material. Then you try to solve the answers. Right. So these are the questions you can solve easily. All multiple choice questions are given. You can solve them and you can prepare for exam well, which may be on Thursday, probably on based on the receiving of question papers. Right? Clear? So that's all for today. So after homework, thank you very much all of you. Have a wonderful day. Thank you.